Hey besties! Welcome to breakfast and math. Welcome to learning how to use a graphing calculator. You're gonna turn it on. Oh, one minute. Spoilers. You're gonna do Y. And then, okay, you know what? It's gonna look like this, but without this. It's just because I already had an equation in there. I'm gonna do my problem. -16 x squared plus, I don't want to teach you how to use the regular buttons on a calculator because hopefully you can read. That sounded really mean, I'm sorry. Okay, here's your equation, right? And then you're gonna go to here and you're gonna hit graph. It's gonna graph. And then what you're gonna do, you're gonna go to trace, and yeah, you're gonna go trace, and then all these numbers are gonna show up. Most likely it'll say 0, 0, but apparently not in my case. And then like Tetris this shit, and I don't know where it is. Okay, you're gonna see a little like spider show up. And when you move it, oh, why does it jump so much? Okay, sure. This is gonna be what you want for the first problem. I am doing the first problem. I did not specify that. I'm sorry. You want it to be here where it hits, but you know what? It just doesn't. It doesn't do that. It just jumps. So that's as close as we're gonna get. It's 3.4. But on here it's 1.4, so 2 number difference.
Hello friends, we are moving on to question 11. Now question 11 starts by asking us, an athlete throws a discus from the initial height of 6 feet with an initial velocity of 46 feet per second. And since number 11 is a 2-part problem, we'll start off with A. A asks us to write an equation that gives the height in feet of the discus as a function of time, seconds, since it left the athlete's hand. Finally, the problem asks in section B, after how many seconds does the discus reach max height, and what is the max height? So there's your 2-parter right there. To start ourselves off, we're going to plot out our equation. This is where you'd plot it. You would basically go to stat plot or y equals on your computer, that little square in the corner, as we've already discussed. And that's where you're going to say plot. And once your plot is set, you're going to check your graph. But you're not done there. Occasionally, your graph may be too large or too small, in which case you're going to go hit the zoom button, and then click 6, and that'll set you to the standard. If that doesn't work, you're going to change your window size by going to the window button and changing your Y max or Y min, depending on whether your graph is maximum or minimum graph. And then depending on, you can change it from 50 to 300 is a typical good range. Just try and keep figuring out what works for you and where you can see the vertex. The question of this piece is kind of just to help you out with understanding your maximum and minimum. You're going to hit second, trace, and then maximum or minimum, depending on whether it's maximum or minimum. Left bound, right bound, guess, and that should give you your estimate.
From our calculations, we can derive that it'll reach its maximum height at 1.44 seconds. We could also determine that the maximum height is 39.06 feet. Moving on to problem 12, it gives us the problem In a shot put event, an athlete throws the shot put from an initial height of 6 feet with an initial vertical velocity of 29 feet per second. After how many seconds does the shot put hit the ground?
Similar to our last problem, this problem is looking for the amount of time, in seconds, that it takes for the shot put to hit the ground. So, let's repeat the process. This time we will be using the equation seen below as a given. This is our graph, very nice. From here we will once again repeat the process of finding the maximum. Leftmost, rightmost, guess. And there we have it. For a refresher, we draw the answer from the x value.
I'm doing the last one now, so thank you, Achilles, for explaining this too. Okay, we're back here. So it's basically the same thing. 0. Okay, so you get your equation, and then it'll graph. That's really small, or it's average. The graph button, and then you hit trace, which is right next to it. And that is directly where I need it. Okay, we're not gonna do that. So it's gonna show up. It's gonna show up as 0, but that's as close to I get it as that. Mine does not go directly on the line. See, it jumps over it. So we're gonna go as close as I can. We're gonna go as close as I can, and it's 0.502. Or 0.638, sorry, I read the wrong one. Looking for your x. So yeah, it's probably as difficult as that is. And then you're gonna clear it and whatever. So, thank you so much for watching.